All right, so welcome to Algebra 2, lesson 10-2. We're simplifying rational expressions, the medium version today. Today's date is Friday, March 27th. So let's move this out of the way. 3/27, 2020. So again, if you're taking notes, I really like the idea of using the Cornell notes. So I'm going to make my, oh gosh, I don't have any tools to make straight lines with this program. Maybe I'll use a different program later. But the first thing is, let's do a review of our procedure. So there were 3 steps, 1, 2, and 3. It's going to be the same 3 steps, but remember, part 1 had 2 pieces to it, and we didn't have to do this piece yesterday. Today, we are going to have to do the second piece, which means I'm going to have to review with you how to do Ninja Star. Yes, India, question.
I didn't mean to press that. I was trying to get my thing to work and it wasn't working.
Oh, yeah, for sure. Okay, so with a yes in the nonverbal feedback, who remembers any of these steps? You can jump to step 3 if you want, although I prefer you to starting with step 1. What are these 3 steps? Oh yeah, I got some hands already. I love this. Yeah, Caroline, go for it.
So for number 1, would it be greatest common factor and Ninja Star?
GCF, and then part B is, yeah, Ninja Star. Perfect, yeah, thank you. What about for step number 2? Yeah, India.
You have to list all the values of x that make it undefined.
List values, man, this program is laggy. This makes my handwriting horrible. Values of x that make it undefined. And I'm noticing when I was looking at Khan Academy, the most common mistakes that people were using, and maybe I can, do I have different colors here? I do, okay. So the most common mistake that people were using is you really need to use the zero product property.
Did I hear Riley?
Yeah, he's in the background watching TV.
Wait, can we see him sitting down?
Sure. Product property. Oh my gosh, why is my handwriting so bad? It's really embarrassing. Let me go ahead and, oops, sorry, didn't mean to do that, Shan. I'm just trying to.
What, sweetie? What's wrong?
All right, so, and then step number 3 is to do what, Beverly?
To cancel out only if you're multiplying.
And yeah, that's one of those things I do in a different color. Only if being multiplied. Perfect, yeah, so those are our 3 steps. Let's do just a review of how to use Ninja Star. And let me take a look at the Khan Academy assignment to see if we need to use Advanced Ninja Star or not. I come here to Algebra 2. I guess either way, we're going to start with a normal Ninja Star. So let's go ahead and call this guy example number 1. Example number 1. So what if I have something like x squared plus 10x plus 20. How do you factor that as a product of 2 linear binomials? And I'll give you a hint. You're going to use this Ninja Star. Let's see if you guys remember how to do that. So I'll give you guys like 15 seconds to attempt this, and then I'll come back and ask everyone else how to do it.
Who's watching SpongeBob? Hey, why'd you mute me?
Oh, yeah, sorry. Okay, so Ellery, go for it. If you want to
So,
go.
sorry, what?
Sorry, I'm all messed up. If you could go and solve this problem for us. I saw that you had the yes and the nonverbal feedback.
Yeah. Okay, so you're going to take the 21 and it goes into like the top section of the x.
and then 10 goes into the bottom. And it's a normal ninja star because it's just x squared, so you don't have to do the other thing. So then what you need is two numbers that multiply to make the top number and add to make the bottom number. So that's going to be 7 and 3 because 7 times 3 is 21 and 7 plus 3 is 10.
Perfect.
So then your values of x are 7 and 3. Or like it's 0, yeah.
You want to go ahead and write out this form where it's something times something?
Yeah, it's 7 comma 0 or 0.
Oh, so you're doing it as if there were x-intercepts. For this one, you're just factoring x something something x something something.
Oh, so it's just x plus 7 and x plus 3.
There it is. Yep. If these were minus signs, then you'd copy the minus sign down here. But we had both of them positive in this example. It looks like Larea, you have your hand up. Yeah, question. Go for it.
So it has to multiply to the top and add to the bottom.
Yeah, exactly. And I guess you don't even need to do Ninja Star. If you are so advanced, you just realize, oh yeah, two numbers multiply to 21 and add to 10. This is just a visual way of doing that. For example, if I switch these around, it would change the question to what multiplies to the bottom and adds to the top. But typically in our class, we always multiply to the top and add to the bottom. It's just a tool that we use. So
the last number goes on the top and the middle number on the bottom.
That's correct. Yep.
Okay.
Yep. And then the other thing, so we don't have any advanced Ninja Stars in this lesson, but we do have a difference of squares. And I ran out of the room here and I can't like scroll down or anything, which is kind of unfortunate, which means I have to do a new screen. So I'm saving the screen in case people need to look at it later, but I'm moving on to the next screen unless in the next 5 seconds, someone tells me go slower. If someone says go slower, then I'll give you more time to copy the sound. Otherwise, I'm clearing the screen in 3, 2, 1. All right, so this next one, again, I'm still doing my Cornell notes. I still have my line over here. Difference of squares. Difference of squares. You still can use Ninja Star. So just keep using Ninja Star. It'll still work. But let me give you an example. So I guess this is kind of like example 2. What if I have something like, let me give you something that has a GCF in it too. What if I give you 3x squared minus 300? How do I factor that? So I give you a hint. It has a GCF. Do that step first, and then you're going to do squares. I'm looking for a yes in the participants window. Who knows what the greatest common factor is and how to factor that out of this binomial expression here? Got some hands. Yeah, let's go with go for it.
So the greatest common factor would be 3.
3, yep. And then when I factor out that greatest common factor, I'm left with
X squared minus 100.
Yeah, perfect. So Beverly has successfully factored out the greatest common factor, which was step 1 that I was talking about in part 1. And then the next part B, I guess, in step 1 is now do Ninja Star. So I'm going to do Ninja Star, but I'll also show you the shortcut if you want to use the shortcut. So Ninja Star means I'm going to make a Ninja Star. So Ninja Star. And I see that there's a missing its middle number. Normally it goes x squared, then x, then a constant number like 100, but it's missing its middle number. If the middle number is missing, then the middle number is 0, which means the middle number 0 is going to come down into the bottom, and I'm going to say 0. If that makes you cringe and like, I don't like that, then really what you should be thinking of is x squared minus 100 is the same thing as x squared plus 0x minus 100. These are exactly mathematically equivalent to each other. Therefore, the coefficient 0 is coming into the bottom of the Ninja Star. Okay, and then the rest of the Ninja Star, through that last term, this negative 100 goes into the top, up here, negative 100. And now I'm going to ask you guys, I'm someone to give me a yes in that non-verbal feedback. What two numbers multiply to 100 but also add to 0? How do I do that? Sorry, Beverly, I can't call on you yet because you just went twice in a row. I can go, however, with India. Yeah, go for India.
Okay, so since it's 0, you need a negative and positive, and a negative 10 and a positive 10 would multiply to negative 100, but also get to 0.
Yeah, there it is. And that's kind of a cool thing, too. So if you ever have a middle term that's 0, you have a very, very high chance of having these both the same number. One is positive and one is negative. That's what it means to be a difference of squares. And then, sorry, India, I'm going to have to unmute you again. But can you now tell me what my new factored form is? Can you rewrite this whole line down here, but factored?
3 parentheses x minus 10 parentheses x plus 10 parentheses.
Done. And box it. Yeah, so that's how you factor that problem. All right, so as a review, the thing that you're going to be doing for all of your factoring is you're going to always check if you have a greatest common factor. Sometimes you might not have to do that, but don't always think that you can skip it. You always check if you have a greatest common factor, and then from there, Ninja Star. Ninja Star still works. The shortcut, again, is take the square root of that term, square root of that term, and then the answer is going to be these, oh my gosh, it's a pair of, oh my gosh, I'm forgetting the word. Does anyone know the word for when these two numbers have different signs between them? Oh my gosh, I'm thinking of it. Yeah, India, what is it?
Is it difference of squares?
So this is a difference of squares right here.
It's 12 o'clock.
Conjugate pairs, that's what these are called. A pair of conjugates. Yeah, I don't know why my brain was just fried. I don't know what's going on. There it is. Okay, so let's go ahead and do our first official problem that might have been on Khan Academy. And again, if you guys are giving me the go faster, go slower, I will pay attention to that. I feel like maybe I'm wasting your guys' time by talking. So here we go. This is now example number 3. So example number 3, go ahead and simplify. Simplify, and you are going to list values that make, I can use the word it, but I want to say the expression, make the expression undefined. So I just want to let Jaden and Aurelia both know that they lost points.
That was my.
Wait, what?
Yeah. I think for this class, because I'm having so many issues of people thinking it's funny and playing background noises, I'm just going to permanently mute you guys and not allow you to unmute yourselves unless you have a quiet raised hand. I'm sorry I have to do that for everyone else. It's a few people, only 2 in this case, that are making it hard for everyone else. Riley just locked himself in the bathroom. All right. And then the problem that I'm going to give you is, hold on, what's going on in the, okay, well, sorry, Riley, it was just one person then. Let's give you x plus 4, oh, hold on, x plus 4, x squared plus 4x plus 3 all over x squared minus 3x squared minus 3. Hey, bud. So everyone is writing down this problem, example number 3. You're factoring the numerator, you're factoring the denominator, and then from there, you are going to set the denominator equal to 0, use the 0 product property,